Let's be real. You've seen the names everywhere. GPT, Llama, Mistral. These AI models have just exploded onto the scene, and they're changing, well, pretty much everything. But have you ever stopped to wonder how they actually work? What is the secret sauce, the core technology that's powering this entire revolution? Well, today we're going to pull back the curtain and unpack the blueprint behind modern AI. To really get a handle on the transformer, you first have to appreciate the sheer speed of the revolution it kicked off. Before 2017, progress in AI language felt kinda steady. But what happened next? It wasn't just progress. It was a complete ground-up transformation of the entire field. And it all happened in just a few short years. I mean, just look at this timeline. It all kicks off in 2018 with the first GPT and BERT models. 2 years later, bam, GPT-3 lands, which was a massive leap. But then the pace just becomes relentless. You've got Llama in early 2023, Mistral just a few months after that, and now we're even seeing these super powerful but smaller models like small LM2. It's just dizzying. So what's the common thread here? What's the engine driving every single one of these breakthroughs?
Well, the answer is a single, incredibly powerful idea. All of these models, even with their different names and what they can do, they're all built on the very same foundational architecture, an architecture that was introduced in a landmark paper way back in 2017. It's called the transformer, and that is exactly what we're going to break down.
So, how does this blueprint actually work? You might be picturing something impossibly complex, but at its heart, the transformer architecture is surprisingly elegant. It's really built from two main parts, and each one has a very specific job to do.
The easiest way to think about it is like a brain with two halves. On one side, you've got the encoder. Its entire job is to read and, well, understand the input. It builds this rich, meaningful picture of whatever you've given it. And on the other side, you have the decoder. It takes that understanding from the encoder and uses it to generate something totally new, like an answer to a question, a translation, or even a story. And here's where the design gets really versatile. Developers figured out they don't always need to use both parts together. You can use just the encoder for tasks that are all about deep understanding, like figuring out if a sentence is positive or negative. Or you can use just the decoder for purely creative tasks, like writing an email from a quick prompt. And of course, you can use them both together for tasks that need to transform an input into an output, like language translation. But an encoder and a decoder, that alone wasn't the revolution. For years, older models really struggled because they read sentences one word at a time. They'd often forget the beginning of the sentence by the time they got to the end. The real breakthrough, the secret ingredient that fixed all of this, is a core mechanism. A concept so powerful, the researchers who invented it put it right in the title of their paper. That's it. That's the title of the paper that started this whole thing. Attention is all you need. I mean, what a bold claim, right? But it just goes to show how truly revolutionary this one concept is. It's the engine that makes the whole transformer architecture sing. A bold title for sure, but what does attention actually mean in this context? Let's make it super simple with a quick example. Imagine we want to translate the English sentence, "You like this course," into a language like French or Spanish. Now, to translate the verb like, any human translator knows they have to look at the subject. Is it I like, they like, or you like? The word ending changes, right? The attention mechanism lets the model do the exact same thing. It learns to pay specific attention to the word you so it can correctly translate like. And it's the same deal for other words in the sentence. To correctly translate the word this, the model needs to know the gender of the noun it's attached to. So, in this case, it pays attention to the word course. This is what the attention mechanism does. It lets the model weigh the importance of all the other words to understand the context, just like we do without even thinking about it. So this is the essence of it right here. The attention mechanism is basically a layer that gives the model the ability to focus. Instead of just chugging along word by word, it can look at the entire sentence at once and decide which words are most relevant to understanding any other single word. It's what gives transformers their incredible contextual awareness. Okay, so we have the architecture and we have its secret sauce, attention, but that brings up a huge practical question. Building one of these models from the ground up is a monumental task. We're talking millions of dollars, massive amounts of data. So how does anyone who isn't a tech giant actually get to use this technology? Well, the answer is pretty cool. It's all about collaboration. The answer is a concept called transfer learning, and the idea is simple. Instead of everyone starting from scratch, the community takes a huge general-purpose model that's already been trained and just adapts it for a new specific job. It's kind of like hiring a seasoned expert with 20 years of experience instead of training a new recruit right out of school.
This whole thing happens in 2 stages. First, you have pre-training. This is where a massive organization invests enormous resources to train a foundation model on like a giant chunk of the internet. This part takes weeks, sometimes months, and costs a fortune. But then comes the second step, fine-tuning. A developer can take that super powerful pre-trained model and just train it a little bit more on their small, specialized dataset. And this part is vastly cheaper and faster.
And it's so important to understand why this matters. Training a model like GPT-3 from zero is, well, it's pretty much out of reach for almost everyone on the planet. The amount of data, the computing power, the sheer financial investment is just staggering. If everyone had to do that, innovation in this space would grind to a halt. And this is exactly why sharing these big pre-trained models is so crucial. It's a game changer. It dramatically reduces the costs, both financial and computational, for the entire community. It lowers the collective carbon footprint of AI development, and most importantly, it lets more people build incredible new things way faster and honestly get better results.
So let's zoom out and tie this all together. We've seen the blueprint, we've seen the attention mechanism that makes it all work, and we've seen the collaborative way these incredible models are built upon. So what does this all mean for the big picture of AI?
I think the most important thing to remember is that the transformer isn't one single model. It's more like a flexible foundational recipe. It's a playbook that has unlocked a whole new way of building AI, one that can be endlessly adapted, scaled up, and improved upon by researchers and developers all over the world.
And just as important is that second piece, transfer learning. That's the practice that truly democratizes all this power. It creates this amazing ecosystem where the cutting-edge tech developed by a few can be leveraged by many, fueling this cycle of innovation that moves way faster than any single company could on its own.
So we've seen that the secret to this current AI revolution is a simple but incredibly powerful idea: attention. It's what allowed machines to finally start grasping the rich context of human language. Which, leaves us with one final big question to chew on. What's going to be the secret to tomorrow's